Hey, what's going on, guys? Let's try this problem right here. So here we have two different spaceships, one is B, one is C, and one of them is launching a missile. The B spaceship is launching a missile, and the question is asking, will the missile hit the spaceship C? Now to find this one out, we have to know this missile's velocity from this person from the Earth's perspective. Now in order to calculate this one, what we have to do is we have to take this part alone and do the calculation, right? Now let's see how we can do it. In order to do this one, we have to use Lorentz velocity transformation equation, that is this one. And let's see. So first of all, we have to calculate this one, we have to set this v. V is going to be the speed that is seen by this person. So let's say this is velocity of the event seen by A. So event, we call this missile an event, right? So this is V is going to be velocity of the missile or of the event as seen by A, right? As seen by A, and we have to know the V prime and U, right? V prime is the velocity of the event seen by this passenger. Let's say we have a passenger in this spaceship. So if he look at this missile, what's going to be the speed of this one? It's already there, that's 0.2 c. So we already know that value. Velocity of the event as seen by B, right? Now we have V prime is available. We have to know U in order to calculate V. Now U is moving reference frame. So we have to set a reference frame. Here if I set this one as this spaceship as my reference frame, the velocity of the moving reference frame is going to be same as velocity of the spaceship, that is 0.8 c, right? So this is going to be U is going to be equivalent to 0.8 c. Now we can go ahead and calculate this V value. V is velocity of the event as seen by this person A. Now, so this person is looking this one from Earth, right? Now let's go ahead and do the calculation. So here we are going to use Lorentz transformation equation, velocity transformation equation. V is equal to V prime plus U. V prime is velocity of the event as seen by B, that is 0.2 c, that's provided. V prime, right? So here V prime is going to be 0.2 c plus U value, moving reference frame's velocity, that is 0.8 c, and then in the denominator we had to have this 1 plus V prime U. V prime again 0.2 c, right? 0.2 c multiplied by U, that is 0.8 c, divided by c square. And here this c square and this c cancels, so we are only left with numbers right here. So if you add them together, that's going to give us 1.0 c, and in the denominator 1 plus 0.2 times 0.8, that's going to give us 0.16, right? This c square and this c square cancel, so we are only left with the numbers. So that's going to give us 1.0 c over 1.16, and if you calculate this one, you should get 0.862 c. So this is going to be the velocity of this missile that's observed by this person A, right? Now we have the velocity of the missile observed by person A. Now what we have to do is we have to set a reference frame, frames of reference from here. So our main question is, will the missile hit the spaceship C? Now in order to know that, we have to know what's going to be the speed of this missile from a person from this spaceship is going to see, right? So in order to calculate this one, what we have to do is we have to set a reference frame like this, moving reference frame. So the speed of the moving reference frame is going to be 0.9 c. U is equal to 0.9 c. Now we have the different U value, right? and here we are trying to find v prime. So this v prime, now v prime is different because v prime is the event speed of the event observed by person from this spaceship. Before we had v prime, that's speed of the event observed by the person from this spaceship, right? No, so our main question is going to be v prime. V prime is what we are trying to find, right? And v is velocity of the event observed by the person from Earth. That's what we calculated. So this is why we calculated this one, so we can solve for this v prime. Now let's go ahead and do that. So first we have to rearrange this equation, right? Because this Lorentz velocity transformation equation is in terms of v. And in order to rearrange, what we have to do is we can bring this denominator and multiply. That's going to give us v times 1 plus v prime u over c square. That's equivalent to v prime plus u, right? Therefore, now let's bring all the v prime to one side. First multiply this one. So this is going to be v plus v prime u over c square, and in the other also we have v right here, and on the other side we are going to have v prime plus u, and if we move all the v prime to one side, that's going to give us v prime uv over c square minus v prime, and in the other side we are going to have u minus v, right? U minus v. Now let's take v prime common. So if you take v prime common, that's going to give you uv over c square minus 1. That's equal to u minus v, right? Now we have to bring this whole thing to other side. Now let's get rid of this part. We need space, right? Let's get rid of these things. Okay. We need this number. This is v we calculated. Now let's go ahead and continue this one right here. So here we are trying to find v prime. V prime is therefore v prime is going to be equal to u minus v over, if I bring this to the other side, that's going to be u v over c square minus 1, right? Now the better arrangement will be opposite side. Like if we multiply this both by -1, this equation is going to switch around. Like we are going to get v minus u over 1 minus uv over c square. Now we can go ahead and plug the values and calculate for this v prime, right? Now v is this value to be calculated, that is 0.862c over 1 minus u value is speed of frames of reference, that is 0.9c, multiplied by v, that is 0.862c over c square. Again, this c square and this c square cancels, and we are going to get 0.862, right? 0.862, and in the bottom 1 minus 0.9 times 0.862, right? So this is going to be our final answer. And here if you simplify and calculate, you will get minus 0.17c. So when the person observed from here, he will see the missile moving backward because we have a negative number. So if this person is seeing this one moving backward, this means this missile will never hit this spaceship, and that's going to be the final answer. The question is, will the missile hit the spaceship C? Since we are getting negative, from this person's perspective, this is moving backward, so this missile will never hit this spaceship, and that's going to be our final answer. I hope you guys find this video helpful. See you next time.